Welcome to Study Loop.
This is the answer to Chapter 22, problem number 11 from the Smith Organic Chemistry textbook. And this problem says, explain why trichloroacetic anhydride is more reactive than acetic anhydride in nucleophilic acyl substitution reactions. Okay, so basically we need to look at what the conjugate base of the or the leaving group, if you will, is going to look like. And so we can draw them for each of these. So for regular acetic anhydride, it's going to look like this. So we can draw it like this. Of course, there's going to be a resonance structure. Oops, I forgot. Sorry, let me move this over a little bit. Of course, there's going to be a resonance structure where we can draw the other oxygen with the single bond and the charge on the other oxygen, or we could draw this as a hybrid where there's a bond and a half to each oxygen and a negative charge shared between the two of them. And that, of course, would be the truer structure, but I'll draw it like this. So this is going to be the conjugate base for the acetic anhydride. And there's nothing beyond that resonance, between the two oxygens that especially serves to stabilize this. However, when we look at the case of the trichloroacetic anhydride, what we see is this. So it's going to look similar, but in this case, we have these three chlorines that are each pulling electron density towards themselves because they're so electronegative. And so that is going to sort of spread the charge that's drawn on this oxygen. It's going to really delocalize it and spread it through this whole molecule because those chlorines are so electronegative. And so as a result of that, it's going to impart a pretty high degree of stability to this conjugate base or leaving group, whatever you prefer to think of it as. And since that's gonna make it weaker, it's going to make it more stable, and that is going to make the trichloroacetic anhydride more reactive. Okay, and that's the answer to chapter 22, problem number 11.